Now students, we will start with the next topic, that is the electron gain enthalpy. Now just the ionization enthalpy, it is the measure of an atom to form a cation. In the similar way, the measure of an atom to form an anion is expressed in term of electron gain enthalpy. Right? So what is an electron gain enthalpy? It is the amount of enthalpy change that will take place when an isolated gaseous atom accepts an electron and gets changed into negatively charged ion. It will be known as the electron gain enthalpy. So, what is the electron gain enthalpy? It is the enthalpy change which occurs when an isolated gaseous atom gains an electron to form negatively charged ion, or you can simply write instead of it anion, to form an anion. Right? Now what does the enthalpy change here mean? Enthalpy change means whether the energy will be energy related, that what energy change is going to take place when an electron is getting added to that gaseous atom. It just means here that if we take chlorine atom, right? This is the chlorine atom. Now, when it will accept an electron, right? Now, this will be isolated and it is in gaseous state. It is accepting the electron and getting changed into Cl negative. Right. So before the reaction, the heat or the energy of the system or of that chlorine atom will be different, and after getting changed into Cl negative, its energy will be different. So that energy difference is denoted by delta H, and it is known as the enthalpy change, and it is going to be here negative. Now it is not so that every time it is going to be the negative, right? So whenever an electron is added to that gaseous atom, the process can be either exothermic or endothermic. So student, in this case, it is exothermic, right? So we can say that electron gain enthalpy involves or involves either release of energy, release of energy or absorption of energy. Right, students? So electron gain enthalpy is going either will be exothermic process if the energy is being released, and if the energy is being absorbed, it will be the endothermic process. Now, how we will determine that which time it is going to be endothermic or exothermic, right? So for it, we will just have this fact in our mind, that if an atom has a greater tendency to accept an electron, if an atom has got greater tendency to accept an electron, that time if the energy is going to be released and it is going to be exothermic process, right? So energy will be released, right, so that the atom gains the stable configuration. The energy is getting released and hence the process at that time is going to be exothermic process. For example, here only I have given the example of fluorine. Now students, if you see here, what is the electronic configuration of fluorine? It is 2, 8 and 7. So you can see that it is missing one electron to get the stable configuration or to get the nearest noble configuration of argon, right? 7 here, it needs only one electron. So it means it will always have a greater desire or greater tendency to accept the electron so that it gets the stable configuration, right? So hence, therefore, in this case, the delta H, that is the enthalpy change of the reaction, is going to be exothermic, right? And it is denoted by negative electron gain enthalpy, right? So electron gain enthalpy can be either negative or can it either be positive. Now we will have an example where we'll have positive electron gain enthalpy. Now students, we have gone through the negative electron gain enthalpy. So the halogens have got the negative electron gain enthalpy. We can say that the halogens have maximum negative electron gain enthalpy, right? Electron gain enthalpy. Now, as I said, that we will also go to the positive electron gain enthalpy. That means delta H is positive. This is for the endothermic. This will be the endothermic reaction. So here it means that these will be those elements, atoms of those elements which have got very either no tendency to accept the electron, right? They have got no tendency to accept an electron, but they are made to accept that electron by giving the energy from the outside. That is the endothermic reaction. Now let's take an example of here, neon, right? So we know that the neon has got the stable electronic configuration. It is 2A, right? If you want, you can write down the simple configuration in this way also. 1 is to 2 is to 2p6. I have written it in a condensed from 2A. It's 1 is to 2 is to 2p6. This is second shell is being completely filled out. Now, when an electron will be added to such an atom whose electronic configuration is filled up, completely filled up, in that case, the electron which has been added, right, is going to, now this will be the case, and this configuration, now this electron which has been added will be added to the higher principal shell, or we can say will be added to the higher shell. Now that state is going to be unstable state, right? The electron which will be added here is going to occupy this one, right? It is the unstable configuration, right student? So to get an electron filled up to the higher energy level, that time we have to give the energy from outside, right? Energy will be given. So that means this system or this atom is going to absorb the energy, right, which will be supplied to it. Hence, it will have the energy supply, endothermic reaction, that means positive. So it will have the positive electron gain enthalpy. The halogens have, right, sorry, not halogen here, the inert gases have positive electron gain enthalpy, or we can say will have highest positive electron gain enthalpy, because here the electron is been added to the, right, it's been added to the higher shell, right? They have got the large value of the positive electron gain enthalpy. Right, students? So that means what can we conclude here? That the tendency of an atom to accept an electron will determine whether the electron gain enthalpy will be positive or negative. Right? And when we say the tendency, it means that if by accepting that electron it gains a stable configuration, it will be eagerly accepting the electron and will change into the negative ion. And as a result, it will have the negative electron gain enthalpy. The energy will be released out. But when it doesn't have the tendency, or it have got the less tendency to accept an electron, right? Or we can say here, let me just correct the statement. If it has got the stable configuration, right, and it has got hence no tendency to accept an electron, so in that case we are forcibly getting the electron in that atom. So here the energy is will not going to be liberated out, it is will be added. We have to get that electron added to that atom by supplying the energy. Hence the electron gain enthalpy will have the positive value. Hope so. Is it clear that when we will have the positive electron gain enthalpy and when it will be a negative electron gain enthalpy? So just go through it. Now students, electron gain enthalpy. So what is the unit of electron gain enthalpy? It is electron volt per atom, or you can express it as kilojoule per mole. Right? So the unit of electron gain enthalpy is electron volt per atom, or it is kilojoule per mole. Electron volt per atom, or we can express it in kilojoule per mole. Right? Now students, just like we have got successive ionization enthalpy, in the same way we have got successive electron gain enthalpy also. So now we are going to discuss the successive electron gain enthalpies. Right. Now let us take an example here first, that if we have got, this is an A atom, right? So it accepts an electron, right? It has a tendency to accept an electron and it forms a negative ion. So here the delta H is negative, right? So we have taken it 1 and have told just now that it has got a tendency to accept the electron. So its delta H is negative. Now students, here the enthalpy change or the electron gain enthalpy is noted by 1 delta H1. Now if this negative ion, A negative, now accept one more electron and it changes to 2 negative, right? Right. Let it be this value delta H2 here. So students, now just a question arises here that A has got a tendency to accept an electron and it has changed into A negative ion. Now whether this A negative ion will have tendency for this electron to change it into A2 negative, right? So here when when the electron was added, it was a neutral atom, right? But now when the electron has been added here in second case, you can see here that here it is a negatively charged ion. So students, what will happen? There will be repulsion between these two negatively charged species. This is one is A negative and this is another negative charge, right? Electron. So here there will be repulsion and A2 negative which has been getting formed, right? And if we compare the electron gain enthalpy of delta H1 and delta H2, definitely the magnitude of we can say negative electron gain enthalpy in the second case is going to be lesser than the first one. So if we just compare these two, that time the delta H2 is definitely going to be less than the delta H1, right? So here it is in term of negative electron gain enthalpy. Right. Similarly, if we add one more electron here, right? That is, if it is again A2 negative and one electron more has been added, getting changed into A3 negative, definitely here this time also delta H3 will be less than delta H2 and delta H1. Hence, we can conclude here that with addition of one electron or with addition of electron to the neutral atom, right, a negatively charged species is formed, which is not going to readily accept the electron which will be added next, right, and hence the magnitude of negative electron gain enthalpy is going to decrease, right. So where successive electron gain enthalpy, so here successive means that's just getting one and one more electron added step by step. So the electron gain enthalpy, the negative magnitude of negative electron gain enthalpy is going to decrease, right. And it may be also that a negative electron gain enthalpy get changed into the positive electron gain enthalpy, right. That means energy will be added to get that electron just added to the that system, to that atom, right students. So just go through it, a successive electron gain enthalpy. So here we can conclude that when the first electron is added to the gaseous atom, it forms a negative ion, and the enthalpy change during the process will be known as the first electron gain enthalpy. So delta H1 is the first electron gain enthalpy, delta H2 is the second electron gain enthalpy, and delta H3 is the third electron gain enthalpy. Right students? So if we just going to see here that, so just no more confusion, just we put here positive because whenever the electron, the repulsion will be there, so we are forcibly adding that electrons and just getting it positive. So with the increase in one and one more electron, the enthalpy will getting changed. First electron gain enthalpy, second electron gain enthalpy, third electron gain enthalpy. First electron gain enthalpy was having the negative value. The second electron gain enthalpy, comparatively the magnitude of negative sign, negative electron gain enthalpy will be lesser, or we can say that it will have the positive because energy will be given to that system so that it accepts that electron overcome the force of repulsion between these two negatively charged species. Similarly, when the third case, the third electron will be added, the magnitude of the negative charge on that atom, right, is more, right. Therefore, more repulsive forces will be there and more energy will be has to be supplied to get that electron added. So it will have more positive electron gain enthalpy. So this is the sequence of it, that here delta H3 will have the lowest negative electron gain enthalpy, or we can say it will have here the positive electron gain enthalpy, right, and gradually this delta H2 will have less positive and delta H1 is having the negative electron gain enthalpy. Students, very important, just go through it properly. Students, we will discuss the factors on which the electron gain enthalpy will depend. So the electron gain enthalpy will depend upon the nuclear charge, atomic size, and the electronic configuration. So we are going to discuss them one by one. So first, let's see about the nuclear charge. Now students, nuclear charge, if the nuclear charge of an atom is more, that means there will be strong force of attraction between that atom and the incoming electron, and hence what will be there? Greater tendency to accept that electron. So it will going to have the higher value of the electron gain enthalpy. That means higher negative electron gain enthalpy. So if the nuclear charge increases, right? If the nuclear charge increases, then what will happen? There will be strong force of attraction between the nucleus of that atom and the incoming electron, and hence there will be greater tendency to accept the electron, and hence large negative electron gain enthalpy. Right? B, large negative electron gain enthalpy. Right? So I think this is clear. Nuclear charge, or we can say nuclear charge and the electron gain enthalpy, they are, we can say, the directly proportional to one another. So if the nuclear charge increases, there will be increase in the negative electron gain enthalpy, or we'll say that the atom is going to have large value of the negative electron gain enthalpy. Right? Now, second factor is the atomic size. Now, the atomic size, if the size of an atom increases, then what will happen? The distance of the of that incoming electron from the nucleus is going to increase. Hence, it will experience less force of attraction, and therefore the atom will have the lower value of negative electron gain enthalpy. Right? So, if the atomic size increases, right? If the atomic size increases, right? There is, you can say, less force of attraction between incoming electron and the nucleus. So, less negative electron gain enthalpy. Right? So when the atomic size increases, there will be less attraction between the incoming electron and the nucleus. So it will have the less negative electron gain enthalpy. Now students, the next factor is the electronic configuration. Now the electronic configuration is going to affect the electron gain enthalpy also. Now if we have the stable electronic configuration, in that case we will have positive electron gain enthalpy. Right? So in this case, electronic configuration, if we have half filled or and completely filled, valence shell configuration, so there will be less tendency for incoming electron, hence positive electron gain enthalpy. Right? So there will be less tendency to accept an electron in that particular shell. Therefore, there will more energy will be required to get the electron jump to the higher principal shell. Right? So hence, the greater will be the magnitude of the positive electron gain enthalpy. Now, students, these are the factors on which the electron gain enthalpy depends. Right? And it affects the tendency of an atom to accept the electron. If it will have a greater tendency, again I am repeating it, if the atom has got greater tendency for accepting that incoming electron, right? So there will be negative electron gain enthalpy, and if it has got lesser tendency, it will have lower value of negative electron gain enthalpy. And if it has got no tendency, right, it has got stable configuration, right, stable completely filled electronic or half filled electronic configuration, right, in that case it will have positive electron gain enthalpy, right? And even the electron gain enthalpy can have a zero value, right? Or we can have a zero electron gain enthalpy also, right? So just go through this, and when we say the zero configuration, electron gain enthalpy, it means that they have no tendency to accept that electron, right? So at that time it has no tendency. That means the electron gain enthalpy, right, the negative electron gain enthalpy is going to get zero, the value is going to get zero. So if we have to add that electron, we have to get the extra energy, right, and that time it will just get the electron gain enthalpy is going to change from negative to the positive value. Good morning, students. Today we are going to continue with the topic electron gain enthalpy. Just a quick recall of it, that what is electron gain enthalpy? It is the enthalpy change which takes place when an electron is added to a neutral gaseous atom to form a negatively charged ion. Now, students, the electron gain enthalpy, it is the tendency of an atom to accept an electron in its gaseous state, right? So the tendency will be more if it has a a desire, or just which favors to get its stable electronic configuration. So accordingly, the electron gain enthalpy can have a negative value and it can have a positive value too. Right. So what is the electron? When it will be a negative, when it has got a strong tendency to accept an electron. And when the tendency of an atom decreases, right, so the value tends to become less negative. So what does the negative sign indicates here? It indicates that the process will be exothermic and energy will be liberated out. But in some cases it is positive, which means that the extra energy, or we can say energy, is to be supplied to get that additional electron into that atom. Now we are going to discuss about the variation. Now before we start the variation, the electron gain enthalpy depends upon the size of the atom, it depends upon the nuclear charge of the atom, and it depends upon the electronic configuration. If the size of the atom is small, nuclear charge is high, and the electronic configuration is unstable, or it is less stable, it is not complete or half filled, in that case there will be the electron gain enthalpy will have the negative values. But if the if the electronic configuration, right, it is stable, which is half filled or completely filled, in that case the tendency of an atom to accept the electron will be almost negligible, and the electron is to be added to the higher energy level, and for that the energy is to be supplied. Now students, we are just moving ahead, that is across the period. Now what happens when we move across the period, right? Let it be here boron. Okay, now let's start with the group 1 here. Let's get here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Now students, here lithium, right? This is the group 1. This is the element of group 1. This is the element of group 2. This is the element of group 3, 4, 5, 6, 7, and 8. Right? Here the configuration is 1s1. Here it is going to be 1s2. Now when we come here, I'm just writing here its outermost shell configuration. So it is 2s2, 2p1, 1s2 is completely filled up here. In the same way, this will be 2s2, 2p2. This is 2s2, 2p3. Oxygen it is 2s2, 2p4. That of fluorine is 2s2, 2p5, and that of neon is 2s2, 2p6. Student, here I have written the outermost shell configuration of these elements. Now students, when we move across the period, what happens? There is decrease in atomic size, right? And there is increase in nuclear charge. Now these two factors, that is decrease in atomic size and increase in the nuclear charge, tends to increase the tendency of an atom to accept the additional electron. So these two factors are going to increase the tendency to accept additional electron. That means the electron which will be supplied is coming from the outside. So hence what will happen? Hence the electron gain enthalpy will be more negative on moving across the period, right? So when we move across the period, there is, we can say, there is more tendency of an atom to accept the electron, and hence the electron gain enthalpy will become more negative on moving across the period. Right, students? Now, that means here, when we coming from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, so the electron gain enthalpy is going to become more and more negative. Now, there is an exception here, that beryllium, that is the group 2 elements, group 15, okay, here just correcting is group 13, group 14, 15, 16, 17 and 18 here. So here this group 15 elements, right, and the group 18 elements, right. So this is group 2 element section, not only beryllium but all the group 2 elements. Similarly, group 15 elements, nitrogen, phosphorus, arsenic, antimony, bismuth here. Group 15, in the same way group 18, right, they are going to show a different behavior here, right. So they will be having the positive electron gain enthalpy. So again I'm saying, repeating here, all the members of a given period, they will be having the negative electron gain enthalpy, and the magnitude of negative electron gain enthalpy is going to increase on moving across the period. Exception is group 2, group 15 and group 18. So students, can you tell why it will be so? So if you check the configuration of it now, for the other groups, we were having the atomic size and the nuclear charge, we have considered it. But we can't forget the electronic configuration concept also. So if you see here, it is 1s2. S subshell is completely filled up, right? Similarly, here it is 2p3. That means one electron in each 2px, 2py and 2pz. That means half filled configuration. Here in the neon or the group 18 members, here it is 2p6. That means here the p subshell is completely filled up. So students, wherever there is half filled or completely filled electronic configuration, so these elements have no tendency to accept the electron in that particular shell, right. So at that time the electron will be added forcibly, so energy will be given, and hence these elements have got the positive electron gain enthalpy. It means that across the period or in a given period, which group will be having the highest negative electron gain enthalpy. So it will be halogen group, that is group 17, we are having the highest negative electron gain enthalpy due to their smaller size and right, and due to their greater nuclear charge. And if you see the configuration of these group 17, right, this group 17 elements, the configuration is 2p5, 2s to 2p5. They need only one electron to get the stable configuration. So they have stronger tendency to accept the electron, and hence easily, readily they will accept the electron and the energy will be liberated out. So they have got maximum negative electron gain enthalpy. So across the period, which group has got the maximum negative electron gain enthalpy? It is the halogen which have got the maximum negative electron gain enthalpy. Now students, we will discuss the variation of electron gain enthalpy on moving down the group. So when we move down the group, there is increase in the atomic size, right? The atomic size increases. Now definitely due to increase in atomic number, the nuclear charge will also increase, but the factor of increase in atomic size dominates as the new shell is being added up. So students, when we move down the group, due to increase in the atomic size, there is increase atomic size, there is, we can say, the tendency of accepting the electron is going to decrease, as there will be less attraction for the additional electrons. So what happens on moving down the group? There is increase in atomic size. As a result, the attraction for additional electron decreases, and hence decrease in the tendency of accepting electron. Therefore, the magnitude of electron gain enthalpy becomes less negative down the group. Right? So when we move down the group, there is increase in the atomic size, and hence the tendency to accept the electron will decrease. So the magnitude of the electron gain enthalpy will become less and less negative. So if we consider the group 1, right, here we have got sodium, potassium, rubidium, cesium. So when we move down the group, there is decrease in the, or we can say decrease in the magnitude of the electron gain enthalpy, that is the value becomes less and less negative, right?